Good evening, friends. Sorry, good afternoon, good morning, anything I can tell because I'm quite far away from you people. See, now here, till yesterday's class, we have seen very clearly what are the relations, various types of relations which are produced from the Cartesian ordered pairs. I told you that relations, once we understood, then only we can understand the functions. So now I would like to go for the definition of functions. Before that, for the benefit of those who missed the previous class, I would like to just describe very briefly about the equivalence relation and just one or two sums in the relations. Let us see first sum. A is equal to, let us say we will take a set A. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. We have taken set A 9 elements. In these 9 elements, I am defining a relation. What I am defining now? Define a relation or from A to A, like in this Cartesian ordered pair, such that the symbol stands for such that the first element in the relation is 3 more than the first element is less than 3, or the second element or y coordinate is more by 3. Such a relation I wanted. What all I'll get, let us see here. First element, if I write 1, I am getting 4, correct? This Cartesian pair should be there here. 1, 4, 4 is available. Next, if I choose, for example, 2, what I will be getting? 2 plus 3, 5. It is there. Next, I will choose 5. 5 plus 3, 8. 8 is also available. If I choose 6, 6 plus 3, 9. There. 7 if I choose, 10 is coming. 7 plus 3, 10 is not there. So close it here. So R is equal to 1, 4, 2, 5, 5, 8, 6, 9. Here, what is the domain for the above relation? Domain for the above relation I am putting in the map so that it will be easy for you. 1, first two coordinates of all these ordered pairs, 5 and 6. What is the range? What is the range? Range is nothing but whatever elements you have mapped. 4, 5, 8, 9. This is the range. But important point I would like to tell you here, this set actually entire codomain is nothing but set of A. 1, 2, 3, up to 9. This entire set is called as the codomain. Range is limited. Range is only those elements which you mapped. 1 you have mapped to 4, 2 we have done to 5, 5 we have done to 8, 6 we have done to 9. So this is sufficient to tell that this is a relation, because every element of this domain is having a unique image in the codomain. Even though more elements are there in the codomain, still this can be considered as a function. So remember that sometimes the codomain may be very big compared to the domain. Now in this case it is big because all the elements of the set A are called as codomain only. But what is range here? As per this equation, whatever elements we got in this range set, those only form the range of this relation. Okay. Now let me take you to the another point. Here, just for our sake, one more example also I'm doing. Let us say I'm having a set A is equal to 1, 2, 3, 4. Okay. Now another set I'm defining. B is equal to, what is the set now? 5, 6, 7, 8, 9. Now only previous example we have defined only one set. Now I'm defining two sets, A and B. Now here I want to define a relation from A to B. How I'm defining the relation now? the sum of the elements of x and y coordinates is equal to 7, where A should be taken from capital A, that is set A, B should be taken from the B. So let us see how to write this relation now. I said first element and second element we have to add and get 7. If you take first element as 1, second element should be 6. So 6 is there in the B. Second element should come from B, first element should come from A. Then next pair I am having from A 2 plus 5 matching. So 7 is coming for me. Then next 3 I will take. If I take 3, am I getting here 4? Is there any 4 here? 4 is not there in B, so I cannot get. 4 if I take here from the domain, no, not possible. So close it off. So what happened now? Only I could get just 2 elements in the R. What are they? 1, 6, 2, 5. So now you tell me what is domain and what is range. Very simple. Domain is 1, 2. What is the range? 6, 5. What is a codomain? Full B. Remember, the elements of B are only called as the codomain here. 5, 6, 7, 8, 9. So is it very clear to you? So codomain forms the all elements that are there in the set. Then domain range is nothing but the images that are one-to-one mapped from domain. The elements of domain will be mapped to codomain, some of the elements of codomain or all the elements of codomain sometimes. So these three differences you should know very clearly. Domains are all x coordinates, then range all y coordinates, codomain all the elements of the set where images are available. That is, in this case, B is the set. Okay. Now, let us understand. Yesterday we have been defining, while defining various types of relations, equivalence relation I defined. Just very quickly I'll clear this and come to the function. What is equivalence relation? A relation is said to be equivalent or equivalence if it is reflexive and it is symmetric, at the same time transitive. Yesterday, if you remember very clearly, I have taken a very big set, like a dice thrown twice. Sample space I have written very big. So I'm just writing them shortly here. 1, 1, 1, 2, 1, 3, 1, 6. Like this, I have written 2, 1, dot, dot, 2, 6. Then 3, 1, 2, 3, 6. If you remember, you please check that again. Lastly, 6, 6 will come. In this particular sample space, what is equivalence relation for me? To this sample space, we are having first reflexive relation. We'll check in the sample space. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. You will find that all belong to the relation that is A cross B. If you see A cross A there, yesterday you can observe that. Now, this is symmetric reflexive relation satisfied now. Then I told next symmetric should be there in the sample space. What is the symmetric in the sample space now? If 1, 2 is there in the relation, then 2, 1 also should be there. It is there in the sample space, whatever we have written. 2, 1 is there, 1, 2 is there. Similarly, 3, 2, if it is there, then 2, 3 should be there. That is also there. In all 36 outcomes, yesterday you please check up in that sample space. All 36 outcomes, if you check up, you find this 3, 2, 3, 3, 5, 6, 6, 5, like that. So symmetric relation is also satisfied. What is the transitive relation? Transitive relation, nothing but if 1, 2 belong to the R and 2, 3, let us say, belong to the R, then 1, 3 should be found in the Cartesian ordered pair. It is there in the relation. So therefore, the outcomes, whatever ordered pairs we have yesterday seen, they form an equivalence relation for us. So this is the thing, reflexive, symmetric, transitive. If these three relations are satisfied by a given relation, that relation is said to be equivalence relation. Now, let us understand now the definition of function. This is what I said now. We have come to the almost very near to the limit theory calculus, for which now function I am defining. Function is a relation. Function is a relation in which every element of domain is having a unique image in codomain. I'll write again this one clearly. Codomain. Please see the definition again clearly. Every element of domain should have a unique image. So let us say this is called domain. This is called codomain. I am having here A, B, C, D, E, F. So let us say A is connected to D, B is connected to E, C is connected to F. Then this forms a function. Here you can see the characteristic what we defined just now. Every image of the domain is this one. First set is called domain. This is called for me codomain. So D, E, F, A, B, C, they are related one to one. Like A is only related to D, B is related to E, and C is related to F. So this is called actually one-to-one function. Exactly one element is connected to one image. This forms a function. If by chance, if A is connected to E, also it is connected to D, then A is having two images, which is not called as a function. So function when we define, see here, for example, if I draw here A, B, C and D, E, F, if A is connected to D, A is connected to E, then not a function. Definition fails here. Each element should be uniquely connected, then only it is called function. This function, now you are seeing in the form of mapping here. Even I can draw a graph. Suppose a function, let us say, I have drawn like this. This is a function now. How to know whether this is a function or not? We have to just check it out. All the inputs, domain side, whatever values are there, these are all called inputs. Codomain side, these are all called as the outputs. So if for a particular input f of a, I must get only one output, or for a particular x coordinate, only there should be one corresponding y coordinate. I should not have multiple y values. See, for example, -2 square plus 2 square, both will give me same output. So if the input for a particular system +2 or -2 is resulting, say, let us say same output, then this is not a function for me at all. Why? Because output is now not, I don't know from the output whether +2 came or -2 came as an input. The choice, I don't know. It is like a traffic signal. Let us say working for both orange and red color together. For only input. Which input is giving me red color? Which input is giving me orange color? I do not know. I cannot specify that time clearly. So I must have unique input. Like -2 if I give, I must get, let us say, 4. If I give another element, I should get 5. I should not have a choice of 2 inputs for one output. So function fails miserably there. So understand now here that all elements of domain particularly should have a unique image. Even another problem is if in the domain, for example, let us say there are 3 elements, and here let us say we are having 4 images. A is connected to 1, B is connected to 2. Not a function, this is also. Why? Because in the domain or input system, what happened? One element is left unconnected. So function cannot be defined at C that time. If C comes, we don't know what output comes. So function is not complete here. So this is also not a function. So the domain side, no element should be left unmapped. No element should be left in domain unmapped. Please remember this. Also, what I said, another thing, no element should have two images. No element of domain should have two images. So under these two conditions, we can say whether a given equation or expression is a function or not. So we can multiple relations we can make, but testing is this. So there is one vertical line test we call, which will say whether the given function, if given a curve or a given line, is a function or not. For example, let us say I have drawn a line like this, 0, x. If you draw one vertical line like this vertical line is cutting or intersecting at only one point. This forms function. This test says that this is a function. If a vertical line exactly cuts the given function, this is a line. This is one expression. Y is equal to, let us say, x. Then if you draw one vertical line, if it is meeting or at only one point, then this is a function. On the other hand, if you are having, let us say, one circle like this I have drawn, then you draw one vertical line. This vertical line is cutting this circle at 2 points. So not a function. So circle cannot form a function. So this is called vertical line test. Vertical line test, that means we will draw a vertical line over the curve, whatever you have drawn on the graph sheet. If this is meeting the curve in 2 points, 2 distinct points, then it's not a function. Whereas a line which meets at a single point on the curve makes a function. This is called vertical test. So did you understand? Now let us come back to the last concept, types of functions. This is just for brushing up only. After that, we have to go to our calculus tomorrow. But right now, I will just define for you what are the types of functions. You have heard of this function, modulus function. This is a very, very important function. What is a modulus function? F of x is equal to x as long as x is greater than or equal to 0. If it is minus x, sorry, the value of function is minus x if x is less than 0. So f of x is equal to x if x is greater than or equal to 0, minus x if x is less than 0. Let us see how to plot this one. So if x is equal to greater than or equal to 0, it is 0. So that means if x is 0, this is 0. If x is, let us say, 1, again x is, f of x is value x only. So 1. If x is 2, this is 2. X is 3, this is 3. So you put the points like this. So you can meet like this now. Straight line. Sorry, once again, I'll draw this line. Yeah. The curve comes in this fashion. 1, 2, 3. 0 also we have to take. 1, 2, 3. 1, 1, 2, 2, 3, 3. Suppose you take negative values. Minus 1 I'll take. If x is equal to minus 1, because less than 0 means minus 1 values I will take. What is f of x they defined? It is called minus x. That means minus of minus 1, which is again plus 1. So even for minus 1 values, I am getting the positive response. Again, let us say minus 2 value for x is equal to minus 2, minus of minus 2 for x is equal to minus 2. For x is equal to minus 1, this will become plus 2. So minus 2 value becomes 2 here. So this curve, almost like inverted curve again, it will come like this. See now, this is called modulus function. So for this modulus function, if you draw a vertical test, it is meeting only at one point. So this is a function. Understood? No? This is a vertical line test. This is modulus function, remember. Then another function is called as identity function. Identity function means your input value f of x is called function. Output is always equal to input. So if you draw a graph again here, it will be like this, passing through horizon. So if you put 0, it will become output is 0. If you put 1, output is 1. If you put 2, output is 2. Like if you want to say in a coordinate system, 0, 0, 1, 1, 2, 2, minus 1, minus 1, minus 2, minus 2, like this. So this is called as far as identity function. Signum function, one more is there. This actually I'm showing you only important ones. Signum function. Signum function is also a very important function for us. It will be like this. F of x is equal to 1 for all x values greater than 0. It is 0 for x is equal to 0. And if it is minus 1 for x less than 0. So now these values, whatever you have seen here, how to represent in the form of a graph? Very simple. See here, this is 1. So for all values more than 1 on the x-axis, it is representing like this. For all values minus 1 below x 0 means 0. Then below less than 0, it is only minus 1. So this is how it is represented. Then one more thing is what for a constant function. Constant function is what? It is very simple. Anybody can do that. Always output will become equal to one constant value. So let us say any input, you give 0, 1, 2, 3, anything, always it will be one parallel line. Like this, okay? 1, 2, 3, 4, 5. So that means you give x here, any number, minus 1, minus 2, 0, 1, 2, like this. Always you'll be getting one constant output, k. So this is called constant function. So hope you are following my explanation. Any doubts, anything are there, you can feel free to ask me. We will go back, we will next class we'll discuss on the introduction to calculus, that is limit theory. Little bit revision I'll do on functions again. Then we'll go to the calculus limits and straight away from there calculus theory. Actually, initially I told you all that we'll start calculus. So I thought this is introductory minimum course needed for understanding the calculus because functions are often used there. So that is why hope now we are prepared or we have come to some level of going ahead with the calculus. I'll meet you in the next class with the introduction to the calculus and little bit of revision on the functions. Have a great day. Thank you all.